I haven't written down the actual example, but at the indicated point, we're going to find three things: the slope of the curve, an equation of the tangent line for that curve at that point, and an equation for the normal line. So we'll go over what a normal line is in a minute. So we're doing this for x squared minus 3x minus 1, and we're doing this also at x equals 0. If it's telling you to find the slope of the curve at a point, at the indicated point, then they need to give you a point. If they're just saying find the slope of the curve, they must mean they're talking about a line, because then it would be the same everywhere. But they would have to give you some point to find the slope at, if that makes sense. So what do? We're not going to use some of us know how to take the derivative. We're not going to use that. We're going to use the slope form, or the difference quotient, the limit of the difference quotient. So that's what we're going to do. So we'll take this will be our x1. Let me write that formula down. So we're going to use that for part A. So A, let's do that. We'll have the limit as h approaches 0, and f of x is this stuff, which is 0 plus h. We don't know what h is. It's just, we're going to let it go to 0. So we'll put it in, and then we'll let it go to 0 and see what happens. So we have h, this inside will be x1 plus h. So then we have x, which is 0. 0 plus h squared. That's nice. Minus 3 times 0 plus h, and then minus 1. And then I have to subtract just the normal function with 0 plugged in. So that would end up being just negative 1. Right? Because that goes to 0, that goes to 0. Sweet! So then that is changing, and then divided by h. So let's simplify on this one. This one is an easy one. So what do we have? We have the limit as h approaches 0. Got to write that every time, otherwise it's not, really the slope at a point. That's a t, not an l. And then so we'd have h squared minus 3h, and then the negative 1 and the 1 cancel out. And then we're dividing by h, so I'll factor out an h. Look at this. Look at this. Because if I evaluate this limit, I get 0 over 0, an indeterminate form. So I'm going to factor out an h. So I get h minus 3, right? H minus 3. Oh. Yeah, let's keep going. And then divided by h, so that cancels out, and the limit as h goes to 0. So this looks like it'll just be negative 3. So for part A, it says, what is the slope of the curve at this point? Well, that slope is negative 3. Let's see what part B says. An equation of the tangent line at that point. Ooh. Okay, so for part B, I'm going to use y minus y1 equals m times x minus x1. Okay, so if I do that, I need m, I need an x1, which I have, and I need a y1, which I do not have. What? This is crazy. I have this, I do not have this. How do I find that y1? Well, plug in my x1 to my equation. y1 is negative 1. Easy. Okay, so y1 equals negative 1. How did I get that? I just plugged in my x1. X1 was given, and m was negative 3. So my equation, I don't have to simplify it or anything. You can if you want to. Minus negative 1, so that's plus 1, equals negative 3 times x minus 0, just times negative 3x. So there we go. There's an equation of the line tangent to this curve when x equals 0. And then the normal, an equation for the normal line. Normal just means the equation for the line perpendicular to the tangent line at that curve, or at that point on the curve. That gets confusing. I just read in the book that I'm using that the Latin word for perpendicular is like normalis. So when they changed it into English, it just became normal. So yeah, there you go. So C, well, we have to find a different slope, a perpendicular slope. So M in our C problem for the normal would be the opposite reciprocal, which means you flip it over and you change the sign. So it was negative, now it's positive. And I do the same thing. The y1 and the x1 are still the same. So y plus 1, right, minus a negative 1, equals 1/3 x. Don't write that on the bottom. Don't do that. Don't do that. Don't do that. All right? So there you go.